Hi everybody, Patrick here from EngineeringShock.com and ElectronicLessons.com. I just wanted to show you the assembly video for our standalone stepper driver module. If you want to see a demonstration, I have another video. Both videos will be included on the eBay listing at ElectronicLessons.com and on our listing at EngineeringShock.com. So what you get here is a monetary push-button switch, a custom PCB, 5 10K ohm resistors, 2-pin terminal block, ceramic 0.1 microfarad capacitor, 100 microfarad electrolytic capacitor, 7805 5-volt regulator, 18-pin socket, program microcontroller, PIC18F, stepper motor driver board plugs into the PCB, a 3-pin header connector, 2-pin header connector. You'll see how that works later. Actually, if you watch the demonstration video, secondary push button switch, and of course your motor. So let's put our resistors in first, and then we'll do our capacitors, and then we'll do some of the bigger stuff. It's actually a very easy kit to put together, so stay with me here. There are 5 resistor slots: R1, R2, R3, R4, and R5, and they're all labeled 10K. So 10K will actually be in the, you can actually see it in the middle of the footprints. Resistors are not polarized, so you can place them in either way. Make sure they're soldered in properly and neatly, flush to the board. Once you're done soldering those into place, we'll do the capacitors. C1 is right here, and that's for our electrolytic capacitor. As you can notice, our 100 microfarad electrolytic capacitor has a short lead and a long lead. Long lead is positive, short lead is negative. On the right hand side here of the footprint, you'll see a little positive symbol. So that means that your long lead is going to go into the right slot, and that your negative is going to go into the left slot, facing the left side of the board. Solder that into place. Be careful, make sure that you have it in the right orientation, or else when you power it up, that cap might pop. The ceramic capacitor, 0.1 microfarad, it goes into the C2 slot. Now, it doesn't have a polarity, so it can be soldered in either way. Solder that into the C2 slot right here. The 2 buttons fit in the 2 footprints, left and right here, labeled forward and backward. They only fit in one way. Line up the holes, pop them in. They should be flush to the board when you solder them into place. The terminal block has a side with 2 screw terminals and a side with just plastic. Make sure that the side with the terminals is facing outwards and not facing the capacitor, or else you're going to have trouble wiring in your power connections. And the 3-pin header goes into the little slot right here. There's 3 pins. It fits in with the smaller pins facing the board, so you have the long pins facing upwards. Solder those into place, and then we will do the regulator and the socket. The 7805 has a side with black and writing on the front, and it's got a back side with ground on it. So let's consider the back a white side. The back with ground on it should be facing the white stripe on the back, so that the front side with the writing on it should be facing the front like so. So make sure you don't solder it in backwards. That would be backwards. This is proper. Solder it in, flush to the board. Your socket has a notch on the left. Your footprint for the socket has a notch on the left. Your PIC, programmed PIC, has a notch on the left. Make sure that you line them up from a bird's eye view. Make sure that when you solder your socket in, that the notch is on the left, facing the resistor, R1, and that when you put the PIC into the socket, that the notch is facing the left, facing R1. If you turn it backwards when you power it up for the first time, you're going to fry it, so be very careful about this. Solder it into place, and we will do the final step, which is to place the motor driver into place. Lastly, what we want to do is make sure that when we solder this motor driver into the slot right here, that it's at 90 degrees. And you want to make sure that the white socket for the motor is facing the front, facing the PIC in this orientation, not backwards. If you solder it backwards, you're going to have a lot of trouble desoldering it, and you might very well harm it when you power it up. So make sure that you're soldering it into this orientation. Make sure it's at 90 degrees. You can have it tipped forward a bit or back a bit. It's not really going to hurt it, but for cosmetic purposes, make sure that it's at 90 degrees. After that, we'll plug in our motor. We've got it all rigged up. On the terminal block, the left pin is your V+ pin. It's labeled on the board, and your right pin is DC ground for your input. Now you need between 7 and 12 volts to operate this bad boy. I'm going to be using my trusty power supply module. Anyway, so I'm going to power it up. And what you'll see is a forward and backward button. Now I've got it in latching mode. This isn't a demonstration video. We're just going to test it. You can use these left pins to control it via your microcontroller. The left pin is here, but you can also use your buttons to operate it. So right now I've got it in latching mode. So I'm going to press the forward button. Now watch the motor head. It might be a bit difficult to see, but watch the motor head. It's turning forward. Now you'll see some red LEDs under here. You probably can't see it, but it's actually showing the sequence in which the motor is being stepped. So I'll press the forward button again. Stops it. I'm going to press the backwards button. Reverses orientation, and it will continue there until either you press backward again, which will stop it, or if I press forward, it will go forward. So 2 presses in sequence starts and stops it. If I press forward then backwards, it'll go forwards and then it'll go backwards. So if I press forward right now, forward, it goes forward, backward, and I'll stop it by pressing backward again. Now press forward, I'll stop it by pressing forward again. Now again, I can do this with my microcontroller, but there's a full demonstration video showing you how to use this. By using my little header here, I've got it in latching mode. So I press it once, or I pulse once to the left-hand pins here, forward and backward pins. It will continue to go in one right or left, based on forward and backwards. If I have it in stepping mode, I'll have based on my demonstration video, I can step it each time I press the forward button, it'll step forward once, or backwards, relative to which button you press or which pin you pulse to from your Arduino. So if you have any questions, please don't hesitate to ask. This can be found at engineeringshock.com and electroniclessons.com, which is our eBay store. It's a fun little kit, easy to do, and just use your imagination as to what you can use on your stepper motor. Thanks for watching, everyone.